By the way, I tried to draw a circle. But it was pointless.
Does that one bother you?
Yeah, because there's points on the circle.
Infinitely many.
What? There's points on it.
It's defined as the set of all points equidistant from the center.
Yeah. If I would draw a circle on the graph, you would go 1, 2, 3, 4.
And then every point is thing.
How are we doing today? So it's tired.
Sleepy.
Alan, pat him on the shoulder.
Did you call me Alan?
Yeah, you said you had to be called Alan. Then.
No, I said Albert.
Albert.
Yeah.
Okay. Yeah, this. Okay.
Did you guys hear about the kidnapping in school?
Oh my
Is this a
God.
joke?
He woke up. Wait.
We already did that one. We already did that one.
What?
Oh yeah, it's okay. He woke up.
That's a joke.
Did you hear about the kidnapping at school?
Yeah, the
The
kidnapping.
kid napping at
Oh
school.
my
Yeah,
God.
we did that yesterday.
It's okay. He woke up. I did not get that. I read it like I was trying to cheat and trying to get it before I went there. I was reading it.
It was a kidnapping.
Why would a kidnapping be okay if you woke up? I was so confused.
Okay.
I actually just.
Anyways.
I saw was it this, yesterday. Luca was getting like physical with some kid down here on the bottom of the stairs.
How was it?
I don't know what it was, but I think he was upset he was off the second floor. He went off on some kid. It was who was it? Somebody in my second period class. Who was it? Luca, you were pushing around. You remember? Huh? No, who was it? It was my second period class.
Right.
Do you remember who it was? Matt, turn around, man. You creepy. All right. Guys, there are three of these that are equivalent to 9x to the fourth minus y squared. Guys, do you guys agree it's a difference of squares? Do you guys agree it's a difference of squares? Which one's a difference of squares here? Whoa. Sorry. Here's one. Right? That's a difference of squares. The middle term would cancel out. What's 3x squared times 3x squared? 9x to the fourth. What's y plus y times negative y? Negative y squared. Okay, so this is one of them. Now, why wouldn't D work? As in dog. Why wouldn't that not work?
Negative y squared is positive?
No, because the negative's not being squared. So this would be negative. Let me get a different color here. This would be negative y squared. The second term fits up. But see how 9's in the parentheses there, guys? What's 9 squared? Because you'd have to square both of them here. This would be 81x to the fourth. That's out. Okay? See how 9's outside the parentheses? It's not being squared. This is 9x to the fourth minus y squared. Yes. So which one's left? Is it A or B? That's the answer. This is supposed to be a 2, I think. It's A, right?
Yeah.
No!
It's
You
A and
dang
B
kids.
At the same time.
Hey, why isn't it A? Here's how you can check A. We got 3x squared minus y, right? See how it's squared? So it means this, right, guys? Come on. You see how they're not a difference of squares? We're going to have a middle term there. 3x squared times 3x squared. We'd get this. That's okay. But then we'd get negative 3x squared y, negative 3x squared y. We'd have negative 6x squared y in the middle. Now, this would be okay. No, absolutely, this would be That'd be positive y squared if I multiply it. So this is out. That would work. Because you'd square 3, 9, square x squared, 4, 9x to the fourth minus y squared. That would work. So those are your three answers right there. Does that make sense? I think that was one of the, how'd we do on that question yesterday, Mr. Westfall? Do you know?
I haven't looked at that one yet. I didn't look at our results on that one. Did you?
Yes.
How'd they do?
I didn't have access to the results.
Why not?
Because you didn't give them to me.
Not as cool as you.
Oh, I'm cool. All right. Okay, we're going to review real quick what you guys. Wait a minute. Where's the tables at? Here we go. What's this? Oh, yeah. That's not yesterday's review, though. We'll come back to that. Let's do this.
What was your takeaway? Like, we've done linear, we've done exponential. What's your takeaway on quadratics when you're looking to see if it's a quadratic or not?
Second differences, right?
Mr. Parker,
What?
you gave it away.
No, I didn't.
I already know what you said.
It's useless.
How do you tell if it's a quadratic?
What Mr. Parker said?
What is it?
It's a constant change.
It with
Linear is constant change.
second difference.
Mr. Parker,
Give it away.
You keep saying it. What? They don't know.
Constant change is difference.
Oh, Mary. Pat her on the shoulder, Alan. Thank you.
did you watch the video?
Nope. Just saying yes, it is.
Oh, yeah.
I didn't watch it.
See?
Do you know what second differences are?
His voice was very sleepy. Like I wanted to sleep. Sorry.
Zachary, go ahead.
Is a quadratic where it just goes through every single, like 1, 2, 3, 4?
Quadratic is it's a parabola.
Yeah, so it goes through all 4 sections. Is that just what that
Four
is?
sections of what?
The graph.
No, it could be. You know when we graphed them and sometimes they only like opened up and they would like start at 2 and they only went up? Like that would never go into the bottom 2 quadrants, right?
Second distance.
So
What?
that wouldn't be a quadratic. then?
Well, a parabola is a quadratic, so it has to have. When you look at the table of values, do you guys remember how we tested for linear? Do you guys remember checking for linear? We went, goes down by 6. If it's linear, it would keep going down by 6, right? The rise and the run are constant. Is this linear?
No.
Because what's the next change?
-2.
Down 2. Then up 2. Then up 6. How do we check for exponential? Times 5 or times 6 or whatever. Times 6. Remember every time? Times 2. 2 to the third, 2 to the fourth. Remember every time it was times 2. Remember? So how do we check for quadratic? Well, it's not linear. It's not exponential. We're kind of narrowing it down to quadratic, but how do we keep going? What's the change in the next row? Well, from -6 to -2, am I going up or down? From -6 to -2, how many?
4. Negative.
Up 4. From -2 to 2, up 4. From 2 to 6, up 4. Ooh.
Wow.
These are called the first differences. The first differences because it's how much y is changing. These are the second differences. Okay, so an example here would be like 0, 3, -1, 1, 2, 3, 4, 5, -2, 11, 1, 5, 2, 11. Here's our parabola. Do you agree, since it's curving, it's not going to have the same slope between those 2 points? Can you see how the slope is changing? So that's why these first differences aren't the same, okay? Because it's not rise and run. It doesn't have a slope. It's the same. But the differences, the second differences, are the same. All right, that's just an attribute of a quadratic function. Every quadratic function has constant second differences. Okay, something you just need to know. So that was in your notes from yesterday?
Mhm.
All right, let's check this one. From 6 to 8, up or down? Up to 8 to 10, up to 10 to 12, and 12 to 14. That has constant first differences. What does that mean? It is linear. And can you imagine that? I go from x equals -2 to -1. I go right 1. I go up 2 from 6 to 8. I go another 1. I go up 2. Up, right? Rise 2, run 1. Rise 2, run 1. Oh, that's linear. Okay. Thank you. Check this one. Was this in your notes or homework? What did you get for this one? Huh? Up 2.5. Up 15. Oh, man. This is growing really fast. Do you agree? At this point, what should we start dropping as options? It's not linear. Mary. We kind of think it's exponential, right? So at this point, I would stop finding the differences, because difference means subtraction. They're not going to be the same. Even the second differences aren't going to even be close. Do you agree? Should we do it just for fun or no?
Yeah.
Okay. Go ahead, Aaliyah. What's 108 minus 18? Good, 90.
90. I knew that. I was just feeling it.
All right, 648 minus 108.
Look at this.
Good, 540.
Basically, it's 540.
What are the second differences? Oh, man. Those are not the same. Those are not constant second differences. Right? Stop. But is it exponential? Well, is there a common factor that you could find between them?
6.
Times 6? Let's see. A half times 3, or a half times 6. 3. 3 times 6. 18. 18 times 6. 108. 108 times 6. Yep. Yep. So it must be an expo marker. I mean exponential function.
Expo dot.
I don't know what that is.
Oh, that's what you wrote.
Time for the review?
We can. What's the next one there? Next slide. Yeah, when we go up to that parabola, we can do that one.
This one?
Go up like 3 slides there. Back. Yeah, right there. Let's do that one. For review, then I can start the review.
You know what's rude? What is this called?
A cube. That's not a
To
cube.
die.
It's a dime.
It's very rude to offer to someone in the incorrect voice. Wanna die?
Yeah.
Dice. Want a dice.
Dies 1. You don't know.
And you.
They seem to roll it.
It's
All right, guys, get out paper. Write that equation down. This is what the review tonight will be. A lot of this. Okay. By the way, on the quiz, kind of started you with the axis of symmetry. Y equals it's negative b over 2a. You have to know that on the quiz.
You do?
Yes. You have to know this. You have to know this. Okay. So what's a here, guys, in this equation? A equals 1. Whoa, come on, sister. A equals 1. What's b? Negative 4. What's c? 1. Okay. Guys, what does c always tell us if it's written in this form? Y-intercept. Guys, so what is it? Y-intercept, bless you. Y-intercept is 0, 1. 0, 1. That's like, can't miss that one. All right. So let's plug in. What's the opposite of b? 4. Right? 2, yeah, because it's negative 4. What's negative 1 times negative 4? 4. 2 times 1 be what? 2. So what is it? And don't forget, write it like that. Okay, now, you don't have this. You might want to, whoops, that's the wrong one. This, what do we got? X equal 2? Whoa, come on, sister. Why aren't you going? Should have went back to a line. That's weird. What? Why isn't it going? It's not writing. That's weird. Try it one more time. There we go. Okay. Remember, that's your axis of symmetry, vertical line. Now, what's going to be on that? The what? No, the vertex. The vertex. Now, how do I get the vertex, guys? Okay. Do you remember how we get the vertex? Plug in 2 here and here. Go ahead and do that. We already got the guys. We already got the x value. We need to get the y value. Plug it in there in your calculators. Let's see.
What do you think the answer is?
I know what it is. I don't think it.
You know the answer.
What'd you get, McConnell? -3. How many got -3? That's what I got. Okay. Now, all right. Watch this, because everybody goes, I don't know how to get the other points. All right, watch. Everybody good on the axis of symmetry? Okay. Is everybody good on the vertex? Plug it in. Okay, so 2, -3. And where are we at? 2, -3. Now, is my problem going to open up or down? +1 there, right? Remember, you draw a little smiley face there, so if you have to graph it, you know it opens up. Okay, now. We already got what, guys? What? 0, 1. Now, don't I have another point already from this? Can I reflect it across to this way? Does that make sense? Okay. Use your axis of symmetry, okay, to reflect the y-intercept across the other side. So there's one of my what? Here's one of my other points. 4, 1. Now, do you guys remember when we graphed a parabola map? We have to plug 2 points eventually into the equation. One to get the what? Vertex. And then another point between the vertex close to the axis of symmetry to get another point, and then we can reflect that. Guys, which point would I use here? Well, we can't use 2 for x because that's the vertex. Can't use 0. That's my y-intercept. Can't use 4. I already have it. Wouldn't it make sense to use 1 or 3, right? I'd probably use 1. It's a little easier to work with, right? So let's pick 1. Put 1 back in there. Everybody do that. Put 1 in there. So we're going to go 1 something. Put 1 back in the equation. Put it in your calculator. What's that? Jonathan? I'm sorry, John. Logan? Do you guys agree it's -2? Okay. So 1, -2. 1, -2. Now, if it doesn't fit in there, it's got to be above the vertex and below the y-intercept. Now, here's another point right there. Right? Reflect that across there. Do we have our parabola? Yeah, we can draw it. Draw your parabola. Don't forget to put arrows up there. Guys, you could have put, what do we got? 1, -2. We already have that. And then you could put 3, -2. You can put that also if you want. You don't have to because we've got our 2 points, other points already. Now, what's my domain? All real numbers. Guys, if you missed that, shame on you. Oh, come on. Now, what about the range? Sabrina, what's my range? What's the lowest point of the graph? For y values. Okay, do they go up or down? So it's got to be greater than. Careful. Doesn't it equal -3? Yeah, it does. Greater than or equal to -3. Now, guys, can't you get that y value right there? Does that make sense? Part of your vertex. If it opens up, it's going to be greater than or less than. Or, excuse me, greater than or equal to. What if it opens down? Less than or equal to, right? All right. I think we'd like you to do
1 through 7.
1 through 7 or 8.
Because look on the next slide. Because it says tomorrow, I think it's going to be, or one more.
Oh, 1 through 8. That's a parabola also. Okay, guys, so do 1 through 8 for tomorrow.
We're working for the rest of class. You're being given a gift of time. Use it. This one you should be working. They're not.
English.
This is the guy that walked. You're not really close to throwing. Is he gonna come around here?
Where's the dog?
Skylar, give him
We should
a
all
look.
stand there and watch him.
Oh wait, he's just not coming in the grass.
It's an NPC.
We should stand there and watch him.
He just walks all the way on the corner of the concrete by the
Is that a
ground,
Dalmatian?
Yeah.
and then
The herd
walks.
Whoa, whoa. It's okay, bro.
Like, see, this is the concrete one, like
I give
this,
you one.
all across it. And this is grass, and he cut, and he went up.